Hello, it's dumplet here. Here's an item on algebra. Determine the remainder when the given expression is divided by 7. Now, credits to Mr. Daniel James Molina. This question came from one of his self-made quizzes. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, at first glance, this is obscure, but a little bit of spoiler here, but this is actually an integer. If you expand it and simplify, it's actually going to be an integer. And some of you guys may be familiar with these type of questions, but some of you guys may just be completely bamboozled by the given. But don't worry, let's just go through the steps to solve this item. Now, this is actually a very common thing, and those two numbers, which are raised to 2021, we can make those the roots to a characteristic equation. Now, whenever you see these types of given or expressions, you would expect it's going to be part of a recursion or a recurrence relation. Now, if you're going to look up Binet's theorem, by the way, the Binet's theorem gives us the closed form. Sorry, it's the closed form of the terms of the Fibonacci sequence. Now, if you know, the Fibonacci sequence only contains integers, but you guys can go look it up. It involves square roots of 5s and everything. So despite having a lot of square roots, it's going to give us all integers. Now, first of all, we have to note what this is, like the given expression. It's of the form c sub 1 times a raised to n plus c sub 2 times b raised to n. C sub 1 and c sub 2 are just constants in this case. For example, as you can see here, these two are just constants. And then if we have a raised to n, b raised to n. Well, in this case, I have the exponent here to be 2021, but this is generally the closed form of the nth term, for example, a sub n of a recurrence relation. Now, we can try to get the equation where these two numbers, underlined in blue and green, for example, we can try to get the equation of the quadratic equation where the green and the blue and the green numbers are the roots. So let's try to do that. Now, focusing on this one, let's take the sum of the roots. If we take the sum of these two numbers, we're going to get 3. So we have the sum of the two numbers, it's going to be 3. So let's just remember that for now. And if we take the product of these two numbers, you'll be getting 4 in the denominator. In the numerator, we're going to get 9 minus 5. So that's just going to be 4 over 4. And it's going to be equal to 1. So the sum of two numbers, sum of the roots is 3, and the product of the roots is 1. So we will get the following equation here. So let me underline this in red. So this will serve as the characteristic equation of our recurrence relation. Now, whenever we have the characteristic equation, all we have to do is the following. Replace the x squared term with a sub n. Replace the x term with a sub n minus 1. Replace the constant term, or x raised to 0, with a raised to n minus 2. Now, obviously, you can make this n plus 2. You can make the subscript n plus 2, n plus 1, and then n instead of n minus 1, and n minus 2. But for in my case, I'll just make n minus 1, and n minus 2 be my subscripts. So if I do that, I'll have the recurrence relation to be this. And I'll just get in terms of a sub n. So a sub n equals 3, a sub n minus 1 minus a sub n minus 2. Now, what do we do with this actually? Because we already have a sub n. Now, this is the closed form technically of a sub n. So we have this recurrence relationship. So surely we'll be able to get n equals for 0, 1, 2, 3, and so on. Since we have a recurrence relation, we can just simply do the following. Let's try to get a sub 0 and a sub 1 so that everything after a sub 2 and so on, we will be able to get via this recurrence relation instead of just substituting values directly. And maybe we'll be able to find some patterns under modulo 7. So before anything else, we have the closed form. So let's substitute n equals 0 and n equals 1 into the closed form and then simplify. Now you guys can work out the maths here. If we simplify the first one, well, since these two are just technically 1s, these two are just 1s. So if we do that, we can get that a sub 0 is equal to 5. Now for a sub 1, we just have to do a little bit more work, but if you simplify that, you're going to get that a sub 1 is going to be equal to 10. So let me put these two numbers in here. Now, to get a sub 2, a sub 3, and so on, instead of relying on the closed form, we can use the following recurrence relationship that we have acquired from the characteristic equation to get the next few terms. And I propose that instead of just taking a look at a sub n, let's try to take a sub n under modulo 7, because we're only concerned for a sub 2021 mod 7. So we're just concerned with the value of a sub 2021 under mod 7. So the 10 here, let's just replace this with 3, because 10 under modulo 7, it's congruent to 3. Now you guys, let's try to do the rest. To get a sub 2, it's 3 times the previous term minus the term a sub n minus 2. So a sub 2 is equal to 3 times a sub 1 minus a sub 0. Now that's equal to 3 times 3 minus 5, that's 4. So 4 is 4 mod 7, so we can just write 4 for that. And all we have to do is just actually continue the pattern. Now if n equals 3, it's 3 times 4 minus 3, that's 9. So let's just take under mod 7, so that's going to be 2. To get a sub 4, 3 times 2, that's 6. We minus 4, it's going to be 2. And you guys can work out each term here, and you might be able to see some pattern. For example, in the 8th, to get a sub 8, it will be 3 times 5 minus 3, that's going to be 12. Under mod 7, that's going to be equal to 5. So in fact, this pattern is just going to hold, and we have here, you guys can fill up the table as follows, and you would kind of see a pattern here, because I'm going to write a box here, and take a look at the 5, 3, 4, 2, 2, 4, 3, 5. It repeats with a period of 8, so it repeats every 8 terms. Now, so we just have to actually just check modulo 8. So since 2021 over here, so since we know that 2021 under modulo 8, that's equal to, you guys can work out the maths here, but under modulo 8, it's equal to 5. So we just compare it with 5 modulo 8. So it's a sub 2021 under mod 7 should be the same value as the value of a sub 5 under modulo 7. So since if n equals 5, a sub n modulo 7 gives us 4, we can conclude that a sub 2021 under modulo 7 would give us 4. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!